This lecture, we're going to look at decision errors in hypothesis testing. That is, when we reject HO, we could either be correct or incorrect. That would be an error if we're incorrect. Or we can fail to reject HO correctly or incorrectly. And of course, if it's incorrect, you've made an error. And we'll also talk about statistical power in hypothesis testing. That is, correctly rejecting HO, finding an effect that really is there. And we'll specifically do that in the context of fixed significance levels when you've set alpha to 0.05, or when you have a critical value that says something like reject HO if z-test is greater than 1.645. So here's just an overview. On the left-hand side here, we have the potential decisions that we might make. The only decisions we can make when we do a hypothesis test are we're either going to reject HO or we're going to fail to reject HO or retain the null hypothesis. On the upper side here, we have the unknown but true situation, reality. And in reality, HO either is true or it's false, in which case HA is true, the alternative is true. So reality versus decisions. And so we could just fill in the boxes here. In the first box, we have the situation where we reject HO, but HO is true. We shouldn't have rejected it. And if that's the case, we will have made what's referred to as a type 1 error. And the probability of a type 1 error is equal to alpha, the level of significance. And that's what we've been using in problems already. We will say something like reject HO if the p-value is less than 0.05. Well, that 0.05 is the chance, the a priori, before you collect any data, chance of making a type 1 error. And the other thing I have here is a false alarm, or you could also refer to that as a false positive. That is, we've identified a situation where we need to pay attention. We've rejected HO, now let's pay attention. But we shouldn't have done that because we shouldn't have rejected it because it really is true. And of course, the other thing that could happen when HO is true is that we correctly fail to reject HO. And you can see here that the probability of that is 1 minus alpha. So if HO is true and there's a 5% chance of getting it wrong, then there's a 95% chance of getting it right. That is, if HO is true, there's a 5% chance of being wrong anyway, and a 95% chance of being correct. So when we reject HO, we could be right. We reject HO, and when we should, HA is the true reality. And the probability of getting it right when HA is true is called statistical power. That is the likelihood of finding an effect when there really is an effect. One thing I'll note here is that this is very tied up into sample size. We won't do those specific calculations in this course, although I may hint at where to do those and suggest some software that you might use to do that. I do want to say that before you collect data, it's a good idea to predefine what statistical power, what level of power you need. 0.8 and 0.9 or 80% and 90% are typical levels. Also define the level of error that you're willing to accept for type 1, and then using those and other criteria that you might have set, then determine a sample size that would allow you to make the correct decision in 80 or 90% of the cases if HA is true. If you didn't get all that, it's okay. I just, at this point anyway, I just want you to recognize that sample size and statistical power are very much interrelated. Of course, if you fail to reject HO and make an error, this is the rest of the thing here. You fail to reject HO and make an error, that's a type 2 error. The probability of that is beta, or I could say, if we want a beta curve, it's not a single value, it would be different for every potential value of HA. For example, if we said, can we conclude that the population mean is greater than 100, then the beta error will be at one level if the real population mean is 101, but a different level if the real population mean is 110. Much lower chance of a type 2 error if it was 110 than if it was 101, because it's harder to detect a difference of 101. And the only thing in this slide I'm really trying to add is the idea that statistical power and type 2 error are probabilities and they add to 1. So if you know that statistical power is 0.8, then the chance of a type 2 error, the chance of incorrectly retaining or failing to reject HO would be 1 minus that, or 0.2. And this is just all of the cells filled in at one time. You can pause and copy that down if you haven't gotten it yet. And then this is just a simpler version of the same thing where I just get the main things here, that you can reject HO and be incorrect. That's a type 1 error. If you reject HO incorrectly, then you're correct. If you fail to reject HO and make an error, it's a type 2 error. And of course, you could also make the correct decision there. And this is the last slide in this one. And really the thing that I want to pay attention to the most in this one is the idea that power is strongly influenced by sample size. And that's because when sample size goes up, standard error gets smaller, sigma divided by the square root of n, for example. N goes up, it gets smaller. And that makes it easier to detect real differences when you have a larger sample size.